All right, hello everybody. This is Miss Pi. I am gone taking all my 5 million kids to the dentist today, so I'm doing this recording, and if you need the substitute to pause it or rewind, just let her know, please. This is kind of what we were doing yesterday. I wanted to show it to you again. Couple things that I did. Number one, I went ahead and saw how long it took me to do 10 revolutions, and I measured the radius from my spine to my fingertips, and then the distance from the center of my head to the tip of my nose, and I got these measurements here and here, and this was my time. Now yesterday I went ahead and had you convert your time per revolutions into how many revolutions it took you or per 1 second, and a lot of you were kind of confused by that. So let's look at this again, and this time don't worry about converting from 10 revolutions to, or sorry, I can't talk anymore. We're not going to worry about seeing how many revolutions I can do in 1 second. We're just going to find our angular velocity with the number of radians it takes to do 1 complete circle, and that's just going to be 2 pi. And then our time for 10 revolutions, mine was 14.42, yours was whatever it was. Okay, so one way we can use that information to find angular velocity is we multiply the number of radians in 1 revolution times the number of revolutions, and then we're going to divide it by our time. Okay, and that will give us how many radians per second our angular speed or angular velocity was. And then to find the linear velocity of the tips of my fingers, now realize the tips of my fingers are way out here, and everything on my body is rotating along my spine, or just the center of my body. So the radius from the center of my body to my fingertips, that will play in, or that's what we'll use to find the linear velocity of my fingertips, or how fast my fingertips were moving through space when I was rotating. So to find linear velocity, I multiply my radius times my angular velocity, and I find out that my fingertips were rotating 143.79 inches per second. Okay, now I want to know how fast my nose is traveling through space. So, you have your little widge that's on the board, and we measured the distance from the center of our head, this is the center of my head, to the tip. I'm trying to draw a straight line, it's kind of hard, to the tip of my nose. Now that's the radius for the nose, or the distance from the center to my nose, okay? And I got that my nose radius was 4.5, and I'm multiplying it by my angular velocity, and I find out that even though everything on my body was rotating at the same speed, the distance I traveled, or the distance each part of my body traveled, is different. So the tip of my nose only traveled 19.61 inches per second, where my fingertips traveled 143.79 inches per second. The difference comes from the radius, how far away each item is from the center of rotation. Okay? So angular velocity is how fast something spins. Linear velocity is how far something travels through space over a given time. So let's look at some of the problems that we have on the rest of the worksheet. We have a circular saw blade, and the teeth, the edge of the teeth are 6 inches from the center of the saw blade, and our saw blade, his speed is 1,800 revolutions per minute. Well, in 1 revolution we have 2 pi radians, and to use our velocity formulas, we have to have our angle in radians, not revolutions. So if I'm making it 1,800 revolutions, then to get angular velocity per minute, then I need to multiply 2 pi times the number of revolutions. That will tell me the total number of radians that the saw blade completes in 1 minute. Okay, then to get the linear velocity, I'm multiplying my angular velocity, the answer I got from up here, by 6 inches, because that's the radius, and that will give me my linear velocity in inches per minute. Well, for part C, we want to convert to feet per second. So my answer up here goes up top, and that's in inches per minute. Then I know that there's 12 inches in 1 foot, and there's 60 seconds in 1 minute. Okay, so then all the numbers in the numerator multiply together, and then divide it by all the numbers in the denominator that were multiplied together. Okay, and that will tell you your linear speed or linear velocity in feet per second. Okay, so the next problem, this time we're not doing a complete revolution. The baseball player is only rotating 120 degrees, and again we need to go ahead and find theta in radians. So we do 120 times pi divided by 180. That reduces to 2 pi over 3. And our linear velocity, angular velocity, they complete this amount of rotation in 0.2 seconds. So we're going to find the angular velocity. We take our angle in radians, so 2 pi divided by 3, and divide that by 0.2 seconds. Okay, that will tell us what our radian per second is. Okay, that's an S. That will give us our radians per second. Remember from Monday, I said you always want your time in the denominator, and you want the value of your time to be 1, either 1 second, 1 minute, whatever, 1 hour. You always want it to be 1. So because the baseball player rotated this far in 0.2 seconds, we divided by 0.2, and that tells us how many radians we can have in 1 second. Okay, then you need to find the linear velocity when the radius is 40 inches and then when the radius is 43 inches. You will get different numbers here because you have different radius values. Once you find that, you'll have your answer in inches per second. Then you need to convert that to miles per hour. Okay, we've done that tons of times. Ask your people in your group if you still need help. And then the last problem, very similar to our circular saw blade, but this time we have 100 RPMs. I will let you guys figure out how to set that one up. All right, so those of you that did not watch the video on angular and linear velocity before now, watch it for homework. Fill out the 2 boxes on the second page of your pink notes. Okay? That will explain what linear and angular velocity are. You need to know that to apply it in the problems that we're doing tomorrow. We are pretty much done with this unit. We just have some application problems that we're going to go over, and then we are going to get ready for a project and then a test. Okay? So we'll do application problems tomorrow. We will work on a project on Monday and Tuesday. And then we will review Wednesday next week and test on Thursday. And then that's the end of the 9 weeks. All right, have fun. Rewind this, pause it if you need to, and I will see everybody tomorrow.